Hello, this is Mr. Wynn, and today's video will be about 6-5 operations with radical expressions. So, look at this table. You gotta be able to simplify radicals. Notice the first two conditions or rules happen automatically when simplifying, but it's the last two that require a little extra work. But basically they say no fractions in the root signs and no root signs in the denominator. So here's our first example. How to multiply radicals. Well, if they're the same radical, so they're both the cube root of something, you can multiply the outside with the outside, the inside with the inside. So outside I have 5 times 3, and inside this cube root, and it has to be the same number, will be the negative 12, the 18, I'll put the things next to each other, the a to the first power, the a squared, the b to the fourth, and the b to the second. Well, if I fix that, I really get 15 in the front, and this cubed root, negative 12 times 18 would be negative 216. A times a squared is a cubed. B fourth times b squared is b to the 6. We need to break down that 216. So 200 and that negative 2, but 216 is, well, we know it's 12 times 18. 12 is 2 times 6. 6 is 2 times 3. 18 is 2 and 9. 9 is 3 and 3. Alright, so from the section before, we know since it's a cube root, we're finding triples and not pairs. Well, here's 1, 2, 3 2's. So 2's going out, the others disappear. There's also 3 3's. So 3 goes out, and the rest disappear. So there's no number inside the square or cube root anymore. Now there's a negative sign. I'm gonna tell you, whenever you have a negative in there and it's an odd root, you need to take out negative 1, because negative 1 times negative 1 is positive 1 times another negative 1 is negative 1. So I take out negative 1, and let's see. I'm gonna divide a cubed. 3 divided 3 is 1, so a is the first comes out. And b to the 6, cube root of that, well, 6 divided by 3 is 2, so b squared comes out. And don't forget about that 15 in the very front. So I gotta multiply this one last time. So 15 times 2 is 30, times 3 is 90. Times 91 is negative 90. And ab squared. And that is the answer. Alright, so as long as they have the same root, you can multiply them, put them together. How to add and subtract radicals. So the reason why we simplify radicals is because sometimes when the terms aren't alike, but when simplified they do match, and then we can combine like terms. So for example, I have square root of 98 minus 2 square root of 32. Square root of 98 and square root of 32 are not the same thing. But if I break each one down and simplify it, so 98 is 2 times 49, and 49 is 7 times 7. Notice there's a pair of 7's, one goes out, one disappears, the square root of 2 stays inside. Now this other one, let's see, 32 is 2 times 16, 16 is 2 times 8, 8 is 2 and 4 is 2 and 2. Here's a pair of 2's, another pair of 2's, and a single 2 that's by itself. A 2 goes out, one disappears, another 2 goes out, one disappears. That last 2 stays inside. And don't forget that negative 2 in front, really. So this is really 4, negative 8 root 2. So when I bring this other thing down, here's the brand new problem. 7 root 2 minus 8 root 2. Well, they both end with root 2, so they're like terms. I can combine that. That's like 7x minus 8x. Well, my final answer is negative 1 root 2. Now, I can show you this in calculator, show that they match. So let's see, calculator. If we do the square root of 98 minus 2 square root of 32, we get this answer, negative 1.414 or so on. It's irrational. If I do negative 1 square root 2, you see the exact same thing. So they're the same, just one's reduced or simplified. Alright, foiling. So you'll make sure you know when to double distribute. Basically, when it's parentheses times parentheses, this is two things times two other things. So we're going to do foiling, I'll say. This thing times both this. Well, number times number, root times root. So 4 times 3 is 12. Square root 3 times square root 2 is square root 6. Remember that the insides multiply together. Alright, 4 root 3 times negative 6. Number times number, so that's negative 24. Square root 3, because there's nothing to multiply that square root 3 with. Then the other one, positive 5 root 2 times both of these. 5 times 3 is 15. Square root 2 times square root 2 is square root 4. 5 root 2 times negative 6 is negative 30 square root 2. Well, we gotta see if any of these break down. 6 is just 2 and 3, no pair, so there's no change really. So I'm not gonna bother with that. That'll stay 12 root 6. Square root 3 is already prime, doesn't break down because it's 3 and 1. But square root of 4, you know, it's 2 and 2, that's a pair. 1 goes out, 1 disappears, so this is really 15 times 2, so that number's 30. I'll just bring these down. They didn't change, so no change there. No change there. We know this is really a positive 30. And this square root 2 doesn't break down, so there's no change there. Negative 30 root 2. That is my answer. So if you really wanted to, you type that in the calculator, but they will match. They'll be the same decimal representation, the same approximation. All right, so far we've had no fractions, but now we will. The last two conditions were no fractions in the root signs or in the denominators. So to fix this, we use a trick called rationalizing the denominator. To do so, all we have to do is multiply the top and bottom of a fraction by the denominator. So for example, we have this 2 divided by square root of 3. It breaks that fourth rule of no root signs, in this case a square root sign, in the denominator. So I'll fix it by rationalizing the denominator by multiplying it by the denominator on top and bottom. So 2 divided by root 3, I'm going to multiply that by square root of 3 over square root of 3. Well, I'm just going to multiply sideways. So tops is 2 times root 3 is 2 root 3. Bottom, square root of 3 times square root of 3 is square root of 9. But y'all know that the square root of 9 is just 3. We could do the tree branch thing, but it's a nice number. The shortcut basically is if you have the same thing inside a square root multiplying the same thing, the square root's going to disappear to be that original number 3. So here's my answer. It's rationalized. There's no square root on the bottom. And again, to show y'all that they're the same, we have the fraction 2 divided by the square root of 3. Oops, wrong thing. 2 divided by the square root of 3 is this. And if I do the other fraction, 2 square root 3 divided by 3, it's the exact same thing. So we're just making it conform to the standards, no square root signs or any root signs on the bottom of a fraction. So here's example 4. We're going to simplify this. Well, this one breaks condition number 3, no square root of fractions. So no fractions inside square roots. So what I'm going to do is I'm going to split this square root up. This turns, I'm going to split it to the square root of x to the 6 on top, divided by the square root of y to the 7th on bottom. So it doesn't break rule 3 anymore, but it breaks rule 4. Remember, no square root signs or any root signs on the denominator. So now we can do the rationalize the denominator trick. I'll multiply the top and bottom by the denominator, which is square root of y over 7. So when I multiply the top out, it's a square root of x to 6, y to the 7th, divided by the bottom, the same thing, so the square roots disappear, it's going to be y to the 7th. Now, we need to simplify the inside, if possible. So that top part, I could take the square root of x to the 6. Square root of x to the 6, I do, remember square root is 2 there, 6 divided by 2 is 3, so x to the 3 comes out. For y to the 7th, if I divide 3, y 6 them, so y3 comes out, and inside stays a y. On the bottom is still y to the 7th. And technically, since I took the square root of x is 6, it was even, and we're doing an even root. When it comes out odd, I need an absolute value sign. The last step is we gotta reduce y cubed divided by y seventh. Remember, we're subtracting. There's more on bottom, so my final answer is x cubed root y all over y to the fourth. Because y3 minus 7 is -4, I have to bring it down to the bottom. That's my answer. We rationalize the denominator. No more square root on the bottom. Alright, and the last thing, using the conjugate to rationalize the denominator. So, as you can see, this breaks condition number 4. But when we rationalize, there's two terms. If there's two terms, we don't just multiply exactly by the same denominator, but it's conjugate. The conjugate is almost the same thing. All it is you change the sign in the middle. So when I fix this, I'll multiply the top and bottom by square root 5. But instead of minus, I'm going to say plus 1. So square root 5 plus 1. Alright, now multiply sideways. Now to make it a little easier for us, I'm going to do the top as its own problem and the bottom as its own problem and put it back together. So for the top, this is 2 times, I'll put parentheses, square root 5 plus 1. Well, that's easy, just distribute. So that's really 2 square root 5 plus 2. That's going to be on the top of my fraction. When I do this other one, however, the bottom, so I'm going to do square root of 5 minus 1, in parentheses, times square root of 5 plus 1. Y'all know you have to FOIL this. So when I distribute, square root of 5 times square root of 5, that's square root of 25, which is 5. Like I said, it's the same number. Inside the square root disappears as the original number. That's going to be plus 1 square root 5. You don't have to write that 1. This is minus 1 square root 5. And this is minus 1. We'll combine like terms. The real part, or the whole part, 5 minus 1 is 4. Now, positive 1 root 5 minus 1 root 5, they cancel. Now, the reason why we use a conjugate is because that gets rid of all the square root signs or any root signs on the bottom. See, my bottom's now a simple, nice 4. So my answer, when I put them back together, is 2 root 5 plus 2 over 4. And although that's good, we got to reduce the numbers because they're fractions. So with this 2, this other 2, and this 4, we don't bother the square root. The GCF is 2, so I'm dividing all those numbers by 2. So 2 divided by 2 is 1. So just 1 root 5. 2 divided by 2 is 1. And 4 divided by 2 is 2. Here's our answer. Alright, here's a practice problem for y'all. If y'all can do it, you should be fine in class. Again, this is Mr. Wynn. Thanks for watching. See you in class.